Hello, my name is Joseph and I am a fourth-year mechanical engineering student. I'm here today to share my research, which I began in September of 2019 and am now finishing up as a second-year URIP student. Specifically, this research surrounds the cross-linking of liquid monomers into polymers. In industry, this is commonly done, and when a light source, for example, UV radiation, is also used to cure the samples, the process is referred to as stereolithography. In this process, uniform UV light can be used to help aid in curing of the material. And when this uniform UV light source comes into contact with the sample, it propagates in a non-uniform fashion. And this non-uniformity results in inhomogeneous mechanical properties. This observation is the basis for this research. This research began with identifying a polymer, specifically PDMS, that with the additions of a photoinitiator described by reference 1, the material becomes sensitive to UV light. Last year, I implemented this process within the mechanical engineering department, and an example can be seen in figure 2 where some samples are being cured with UV light. To characterize this viscoelastic material, I'm using the standard linear solid model described by reference 2. This model consists of a long-term modulus plus the summation of decaying exponential components. Figure 3 shows mechanical testing results, specifically relaxation tests, where samples are pulled to a defined strain, in this case 100%, and then held there. The stress results decay over time as the polymer chains align within the material, and it can be seen in figure 3 that a UV exposed sample has a lower viscoelastic modulus compared to a sample that has no UV exposure. Moving forward, I will be changing the independent variables, including the photoinitiator, the crosslinker, and the amount of UV exposure to characterize their effects on the mechanical properties of this material. This research is intended to be utilized by manufacturers to optimize their curing processes. I would like to thank Dr. Sane for her help over the past 2 years and also funding from the university. Thank you for watching.